In this iMachining tutorial series video 2, we will go over how to use the iMachining wizard. This will include step down, the machining level slider, output cutting data, the dynamic 3D preview window, and effects of turning the wizard off and back on. This video will start exactly where we left off in video 1 of the series. The technology wizard is an algorithm for producing on-the-fly cutting conditions for the current operation. By clicking on the Technology Wizard branch, we can bring up the Technology Wizard dialog where the cutting conditions are shown and selected. There are 4 sections of the Technology Wizard dialog: Step Down, Machining Level, Output Cutting Data, and the 3D Preview window. For this example, we will use millimeters and set the depth to a nominal 30. The step-down section consists of input options and the output grid. The output grid has 3 columns: number of steps, step down, and ACPs. Rows are created for each step-down value that is not the same. The ACP value coincides with the color of the step-down row. We will focus on the ACP value later when discussing defining a tool for iMachining. The step-down by default is set to automatic. Automatic will provide step-downs based on tool information and the pocket depth. There are 2 radio buttons for selecting the way the wizard calculates the depths: automatic and user-defined. Automatic generated 2 depths at 15 millimeters. Let's calculate and simulate the toolpath using these step-down values. We can see the 2 step-downs in HostCAD. Now let's set the radio button to user-defined. If the drop-down is set to number of steps, the total depth will be divided up by the number of steps. Let's enter 4 steps in the input field text box and simulate the results. If the drop-down is set to step down, the value in the input field text box will be used for the depth of each step down until the total depth is achieved. Let's enter a 3 millimeter depth. The results are 10 depths at 3 millimeters. Let's calculate and simulate. Now, when the drop-down is set to step down, it is possible to enter a step down deeper than the cutting length of the tool. In this case, the cutting length is 24 millimeters. Let's enter a step down of 30 millimeters, the full pocket depth. Let's look at the results. When the drop-down is set to number of steps, it is not possible for the wizard to generate depths greater than the tool cutting length. Let's try to enter 1 step down. The results are 1 depth at 24 millimeters and 1 depth at 6 millimeters. Let's simulate the toolpath. The 2 depths are shown. To get the wizard to calculate 1 step of 30 millimeters, we will need to edit the tool and change the cutting length equal to or greater than 30 millimeters. Now the wizard can calculate the full depth. Let's return the cutting length to the original 24 millimeters. The machining level section consists of a slider that is used to select from calculated sets of cutting conditions. The slider is made of 8 levels. Each level represents more metal removal rate and higher aggressiveness. The Output Cutting Data section consists of two different ways to view the final data from the wizard that will be sent to the toolpath. View 1 shows spindle speed, feed rate, step over max, and step over min. View 2 shows cutting speed, chip thickness, cutting angle max, and cutting angle min. The output cutting data should be monitored while using the machining level slider to choose a set of cutting conditions. There are many factors in machining that can make one set of cutting conditions better than another. Some of these factors are fixturing stability, cutting tool quality and stability, and/or risks associated with the forces from higher metal removal rates. The milling level slider provides the user with an adjustment for these factors. The 3D preview window provides a 3D representation of the selected cutting conditions. The 3D view shows tool diameter, tool length, tool cutting length, step down, step over, and aggressiveness. The tool is shown in two colors, yellow for the cutting length and gray for the remaining length of the tool. If there is more than one step-down value, the largest step-down from the step-down grid will be used, since this is typically the most aggressive step-down and should be monitored. The side step is represented by the red section in front of the tool. As the milling level slider is used to select the cutting conditions, the 3D preview window updates. Levels 1 through 5 contain different side step values. The remaining levels have a consistent step over. The aggressiveness is represented by the chips behind the tool. The 3D chips change color, quantity, and size to show that moving up in milling levels produces thicker and more chips with greater heat. Also, the 3D preview window shows how the chip should be evacuating the cutting area under good conditions when actually machining the part. The chip should be coming out the back of the tool. If the chips are sticking to the tool due to heat and are being brought back into the cutting area, then the potential for failure is high. The wizard on-off button controls if the output cutting data is being written to the toolpath or not. When the wizard is on, the output cutting data is being sent to the locations in the operation dialog to be calculated along with the final toolpath. Spindle speed and feed rate are being sent to the data tab in the tool branch. Cutting angle min and cutting angle max are being sent to the technology tab in the technology branch. The depths are being sent to the technology tab also. All these fields are locked from being changed and are shown with a lock icon. When the wizard is off, the lock icons disappear and the fields are open to be edited. The wizard can still be used, but the output data is not being written to the fields, and no changes to the toolpath or G-code will be seen. Turning the wizard back on will sync the output values with the dialog and put back the lock icons. And this concludes video 2 of the iMachining tutorial series, where we went over how to use the iMachining wizard. Thanks for watching. Please join us for video 3 of the series, using iRest and iFinish.